Now, the second example for today under bearing, we have it to be an aircraft takes off from an airstrip. An aircraft takes off from an airstrip at an average speed of 20 kilometers per hour on a bearing of 52 degrees for 3 hours. It then changes course and flies on a bearing of 28 degrees at an average speed of 30 kilometers per hour for 1.5 hours. Now, the question says, find its distance from the starting point. Find its distance from its starting point and the bearing of the aircraft from the airstrip. The bearing of the aircraft from the airstrip. Now, to solve this, we will draw a diagram. But before that, we know that we have speed, we have distance, and we have our time. We have our speed, we have our distance, and we have our time. So the first thing for us here to do is to find our speed to find the distance for the first course and the second course. Since we have a distance of 20 kilometers per hour at 52 degrees for 3 hours, and we also have 30 kilometers for 1.5 hours. So we have speed, which is equals to distance over time. So our distance here will now be speed times time. So our distance here for the first course will now be 20 times 3. So we have it to be 60 kilometers. We have to be 60 kilometers. Now for the second course, we have it to be 30 times 1 hour, 30 minutes. That's 30 times 1.5 hours. 30 times this will give us 45 kilometers. So we have it to be 30 times 3 over 2. 2 here 1, 2 here is 15. 15 times 3, we have it to be 45 kilometers. So we have 45 kilometers here. Now, what do? We've gotten our distance, then we make our diagram. So we have two different distance now. We have our 60 kilometer distance and we have 45 kilometer distance, where we have the first one under bearing of 52 degrees and the second one under bearing of 28 degrees. Under bearing of 28 degrees. 52. So for the first one, we have at 52 degrees, we have it to be 60 kilometers. Now, at 45 degrees at 28. So drawing our diagram where we have this at 52 first, this is 60 kilometers. We also draw at 28. At 28 degrees, this is 45 kilometers. This is 45 kilometers. So here is 52 degrees. So now we can just join from here. So we have our diagram to be something like this. So we can just make this as y. Can make this to be y. Now, the first things first, we have here to be our y. This is, we can just make it as x. This is big Y. It is north, west, south, and east. So we have our x, y, z. We have our x, y, z. This is x, y, z here. So this is our north. This is south. This is east. This is west, and this is east. So now our x, y, and s here is 52 degrees. So we have our x, y, s to be 52 degrees. The other part will now be 90 minus 52 degrees. We have it to be 38 degrees. So here is 38 degrees. So we have that place to be 38 degrees. So if you are now to add of w, y, x, will now be, so our 38 degree will now be w, y, and x. Now, for our y, we now have it to be, for our y, we now have it to be 28 degrees plus our 38 degrees plus our 52 degrees. So we now have our y to now be 90 plus 38 plus 28. And we have this to be 156 degrees, which is this part here. This is now 156 degrees. So now we've gotten our y. Now, using cosine rule to find our y squared, using our cosine, we've gotten our y, we've gotten our angle y. So to find the length of y, we use cosine rule. Using our cosine, we now have it to be y squared to now be x squared plus z squared minus 2xz cos y. So our xz plus z squared will now be 45 plus 60 minus 2 into 45, 60 minus, okay, cos 156 degrees. Where we have it to be 180 minus 156 degrees. So continuing further, we have this to be 2025 plus 3600 minus 2 times 45 times 60, which is 90 times 60. We have it to be 5400 times minus cos 180 minus 156. So here we have it to be 5625 minus 5400 times minus cos 24. So we have this to be 5625 plus 5400 times cos 24. We have it to be 4933. We have it to be 4933, where we have this to be 10558. Now, to find the square root of this, our y will be giving us 106 kilometers. 106 kilometers. So the distance from the starting point is 106 kilometers. That is the distance from the starting point, which is this, is now 106 kilometers. That is our starting point. Now, the bearing of the aircraft from the airstrip, we then use our sine rule. Using sine rule, we now have x over sine x equals to y over sine y. Now, we have 45 over sine x equals to 103 over sine 156. So we have our sine x to be 45 times sine 156 over 103. So our sine 56 is also our sine 24. So our sine x will now be 45 times sine 24 over 103. So our sine x here, where we solve it further, our sine x will be giving us 1.2497. By 1.2497, and our x will then give us 10.24. 10.24 degrees. So we have 10.24 degrees. Now, the bearing of the aircraft from the ship, will now be 52, our 52 degrees minus this 10.24. The 52 degrees, which is the starting bearing, the bearing that it was at first, at the start of the taking off of the aircraft, was 52 degrees. So the bearing of the aircraft from the airstrip will now be 52 minus this 10.24. So we have this to be 41.76. Approximating it, we have it to be 42 degrees. So the bearing of the aircraft from the airstrip is now 42 degrees. And this brings us to the end of our class on bearing, where we solve the different examples on bearing using the sine rule and the cosine rule from our trigonometry class. Do subscribe to our videos, like and comment, and subscribe to our YouTube channel. And I'll be seeing you in the next class. Thank you.